This training video is about achieving good machine alignment. In rotating machines, almost 50% of all breakdowns are caused by misalignment. Most machines consist of two parts, a drive unit and a driven unit. When conducting an alignment, the drive unit is generally the part of the machine set that is moved or adjusted, while the driven unit remains fixed. In this video, we will refer to the driven unit as the stationary machine and the drive unit as the movable machine. Shaft misalignment can occur in two ways: parallel misalignment and angular misalignment. In reality, the misalignment of a machine set generally consists of a combination of both angular and parallel misalignment. In operation, this combined misalignment phenomena will increase the loads on the machine parts and create higher than normal vibration levels. This will cause premature wear of the couplings, bearings, seals, and significantly increase the energy consumed. To help make the alignment of the machine a simple operation, SKF has a new alignment tool. Whilst the unit uses the latest in laser alignment technologies, it is designed to be simple to operate. This video will show how easily this tool allows you to align two shafts with great accuracy, and thus prevent costly machinery breakdowns and excessive energy consumption. The SKF alignment tool is supplied in a sturdy carrying case and consists of two measuring units providing the laser beam and the positioning detector, a display unit which will calculate and guide the alignment process, a measuring tape, two chain fixtures, a sample set of pre-cut machinery shims, instructions for use, and a set of alignment reports. When attaching the chain fixtures to the shafts, ensure that the S-marked unit fits the stationary machine, and the M-marked unit is fitted to the movable machine. Now connect the measuring unit cables to the display unit, ensuring that the S and M cable markings correspond to those on the display unit. First, select the dimensions you prefer to work with, millimeters or inches. Before the alignment can commence, some measurements need to be entered into the display unit. Now you can follow the display instructions step by step. Enter the distance between the measuring units. The distance between the measuring unit of the movable machine and the front feet of the movable machine. The measured values can be adjusted by pressing the plus and minus buttons. By pressing the Next button, the values are confirmed. And finally, the distance between the front feet and the rear feet of the movable machine. To commence the alignment, adjust the laser beams. The beams can be adjusted in height and sideways. Before continuing with the actual measurements, don't forget to open the targets in order to allow the laser beams to reach the positioning detectors. For the alignment tool to calculate the machine adjustment values, we use the analogy of a clock. Measurements must be taken at the 9 o'clock, 3 o'clock and 12 o'clock positions. These positions are determined by viewing from behind the movable machine. The spirit levels on the two measuring units will assist in obtaining the exact position. The blinking symbol on the display indicates when to move the measuring units to the 9 o'clock position. Confirm the measurement input by pressing the Next button. Following the same procedure, move the measuring units to the 3 o'clock position. Confirm the input values by pressing the Next button. Repeat the procedure at the final 12 o'clock position. The display will now show the height of the two machines relevant to each other. On the left side of the display, you can see the angular misalignment, and on the right side, the parallel misalignment. These display values should be considered as if you are looking at the side of the machine. Refer the displayed values to the tolerance specified by the machine manufacturer, or against the general recommendations provided in the alignment tool instructions for use. If the displayed values are outside the recommended tolerances, press the plus button to obtain the alignment correction values. Remember, all adjustments must only be made to the movable machine. A negative value confirms that the machine needs to be raised, and a positive value means it needs to be lowered. Any height adjustment made will be shown on the display until the right position is reached. The pre-cut machinery shims will simplify the process of obtaining the correct height adjustment. After correcting the height adjustment, you are now ready to determine the sideways misalignment values. The blinking symbol will indicate the need to move the measuring units to the 3 o'clock position. Confirm this position by pressing the Next button. The display now indicates the sideways position of the two machines relevant to each other. These display values should be considered as if you are looking from above the machine. Again, check the value against manufacturer's tolerance recommendations, or those indicated in the alignment tool instructions. By pressing the plus button, the misalignment correction values will be displayed. The left-hand value indicates how much to move the machine's front feet, and the right value, the rear feet. A negative value indicates that the movable machine should be moved to the right, and a positive value to the left. The left and right direction is determined when looking from behind the movable machine. Any adjustment made will be shown on the display until the right position is reached. In order to record your alignment operation, always fill out the SKF alignment report. Good alignment enables you to reduce noise, reduce vibration and energy consumption. At the same time, it increases the service life of the bearings, the seals and the couplings in your machines. In the process of reducing maintenance costs, SKF now offers its shaft alignment tool TMEA1. Easy to use, accurate, quick and affordable. Contact your nearest SKF representative for more information.